Hello everyone, in today's video we are going to be learning the action potential of the heart. So the cardiac action potential is a very important concept in physiology, so we are going to be discussing it further today. So this graph shows us the cardiac action potential. To begin with, the cardiac action potential is around 105 millivolts. This is because it goes from a very negative value, which is around negative 85 millivolts, to a slightly positive value, which is plus 20 millivolts. So this gives us a total of 105 millivolts of action potential. After that, after the depolarization, we get a plateau, as you can see right here. Okay, and after this plateau, there is abrupt repolarization. So this plateau is what causes the cardiac action potential to last longer than that of the skeletal muscle. Here is the difference between the cardiac and the skeletal muscle's action potential. So in the skeletal muscle, there is a sudden opening of the large number of sodium channels. So the sodium goes from extracellular to intracellular. Okay, this is the depolarization. After that, the fast channels of the potassium abruptly close, causing the repolarization. Okay, whereas the cardiac muscles, we have two types of channels. There are the fast channels, which are the same ones that we discussed in skeletal muscle, and the slower channels, which remain open for a longer time. So, here are the phases of the action potential. Phase zero is depolarization. So basically, the fast sodium channels open, causing rapid flow of sodium into the cell and causing depolarization. Phase one is the initial repolarization, where the fast sodium channels close and the potassium channels open. So, like the potassium leaves the cell through the open potassium channels, causing the initial repolarization. After that, we get the plateau. So the potassium channels close and the calcium channels open. So the fast potassium channels close and the calcium channels open, causing increased calcium ion permeability. So the calcium can enter the cell, and this is what causes the plateau. Okay, so the plateau happens due to the calcium going into the cell. After that, the calcium channels close and the potassium opens again. Okay, so this is what ends the plateau and returns the cell membrane to resting level. Okay, so these potassium, after the potassium channels open, we get the abrupt repolarization. Okay, so the resting membrane potential is around negative 80 millivolts to negative 90 millivolts after repolarization. I'm going to give a brief summary of what we discussed to make things clear. Okay, so to begin with, there is depolarization. After that, there is initial repolarization. Then there's a plateau. And after that, there's abrupt repolarization. So, wait 1 second. Okay, I'm going to like show you them on the graph right here. So this phase right here, this one is the depolarization, where the sodium channels open, allowing sodium in. This plateau, okay, then there's initial repolarization due to the potassium channels opening and the potassium leaving the cell. After that, there's a plateau due to the calcium channels opening and calcium entering the cell. increased calcium permeability, and after that, the abrupt repolarization. And the resting membrane potential becomes around -80 to -90 millivolts. So that was the lesson. I hope you understood it. If you have any questions, please leave it down in the comments and don't forget to like and subscribe to this channel.